Section 2.7, derivatives and rates of change. So we're going to return to the tangent and the velocity problems that we started this chapter with now that we can calculate slopes algebraically. Okay, so the first thing we're going to talk about is a tangent. Remember, a tangent is a line that just touches the curve once. Okay, so given a curve, over here, the green curve is f of x, and we want to find the tangent to the curve at a f of a. Okay, consider a nearby point, x f of x, connect the two. So now we have a secant line. Okay, so between a and x, over here, this line is a secant line. What is the slope of that line? Well, it would just be what? F of x minus f of a over x minus a. That's just your slope formula. Y minus y over x minus x. Okay, what does this stand for? This is the slope of the secant line. Okay, so this is slope of secant line right there. Okay, now if I want to find the slope of the tangent line to that curve, well, if you think about it, go back. The slope of the tangent line is if I'm going to take this point, and if I move it closer and closer and closer and closer to this point, the limit of those answers, those slopes, will be the slope of the tangent line. So now we can actually use limit notation. The slope of the tangent line would equal what? The limit as x gets closer and closer to a of f of x minus f of a over x minus a. Okay, so again, all that's doing is that's bringing the 2 points closer and closer and closer together. There's the notation for that. Okay, what we need to remember, a is the x value of the point of tangency. Okay, so a is your x value of the point of tangency, where you're trying to find the tangent line slope of tangency. Okay. Another expression that I can use for that same situation is if I look at the same exact thing, same graph. Here, this was a f of a. Now if I take a nearby point and I call it a plus h and f of a plus h, as its two values, a plus h, okay? So this is still a f of a. Now I'm saying if I go a little bit further, if the distance between here and here is h, so this point would be whatever this x value is, plus h, okay? So another expression for the slope of tangent lines is the limit as h goes to 0 of what? F of a plus h minus f of a all over h. These are both slopes of tangent lines. Okay, it's just different notation. This is if I take 2 points, x f of x and a f of a. This one is if I take a f of a and a plus h as the next x value. Okay, so now when I want to find the equation of the tangent line, I do not have to keep plugging values in. I can actually use those definitions. Okay, so the first one is I can say what? This is going to be the parabola y equals x squared at the point 1, 1. So a is 1. The x value of the point of tangency would be 1. Okay, so now to do this, the slope would be, the limit as what? X approaches a, which a is 1, of f of x minus f of a, which is 1, all over x minus a, which is 1. Now, just do this out algebraically. Okay, we know that the f of x is what? X squared. So this just becomes, as x approaches 1. So this just becomes the limit as x approaches 1 of x squared minus 1 over x minus 1. So all I did was f of x is the function. F of 1 is the y value when x is 1. Now we know how to find that limit. So you would factor, you'd cancel, you'd plug your value in, and you should be able to do all of that, writing it out, and you should get 2. Okay, now using the other formula, if I use the h formula, which I'll refer to it as constantly, okay, so the slope is going to equal the limit as h goes to 0 of what? F of a plus h. So f of a is 1, remember. So 1 plus h minus f of 1 all over h. So now plug 1 plus h in. So this would turn into the limit as h approaches 0 of what? 1 plus h squared minus 1 over h. Again, this looks familiar. This is one of our limits. You could FOIL, simplify, cancel, and again, you should get 2. I'm leaving all that work up to you. You know how to do that. So either way, the slope of the tangent line at 1 is 2, using the 2 formulas now. Okay, next is just another problem. You could pause it if you want. You could try to do this. Okay, I'm going to set them up, and then I'll probably leave the algebra up to you again. Okay, so the first thing it's easiest to do is say, what is A? A is 3. Okay, A is the x value where you're finding the tangent line. So the first formula would say limit as x goes to 3 of f of x, which is what? 3 over x, minus f of a, which is 1, over x minus a, which is x minus 3. Okay, how do you do this? Limit, common denominator, simplify, and you should get negative 1/3. Again, I'm leaving the algebra up to you. Okay, I'm just setting it up using the definition, and then you're going to use everything we just did with limits to actually calculate that limit. What does that stand for? That is the slope of the tangent line right there. Okay, if I do the other formula, just for setup, I would have limit as h goes to 0 of what? F of a plus h. So it would be f of 3 plus h minus f of a, which is f of 3, all over h. Plug these in, so I'd have limit as h goes to 0 of what? Plug that in, and I would get 3 over 3 plus h. That's f of a plus h minus 1 over h. Common denominator, you get the h to cancel, then you can plug 0 into the equation, and you also should get negative 1/3. You should be doing that out in your note sheet, both of them, as practice. Okay? So now the problem said find the equation of the tangent line. So now I just have to put that together. What would the equation of the tangent line be? Y minus the y value, which is 1, equals the slope, negative 1/3, times x minus the x value, which is 3. So here's the xy value, xy. The slope is what we found at using the formulas. Okay, another problem. You guys could, again, pause and do this out. Find an equation of the tangent line to that function at x equals negative 1. So right away, I know that a equals negative 1. It's not giving me the y value, but you could just take negative 1, plug it in here to get the y value. Okay, so I'll set them up. If I set up limit as x goes to negative 1 of f of x, which is 2x squared, minus 16x plus 35, minus f of a, which you should get 53, all over x minus negative 1, which would be x plus 1. Okay, simplify the numerator, factor, you should get the x plus 1s to cancel, and you should get negative 20. Again, there's a lot of work from here to here that I'm leaving up to you. Simplify, you're writing the limit each time, you're factoring, and you're canceling. Okay, using the other formula, I'd have the limit as h goes to 0 of f of a plus h. So I would plug what? What's a plus h would be negative 1 plus h, and I'd plug it in here, negative 1 plus h squared minus 16 times negative 1 plus h plus 35. That's f of a plus h minus f of a, 53, all over h. You simplify, I would FOIL, I would distribute, combine like terms. Again, you should get negative 20. Okay? And then putting it back together, write the equation of the tangent line. So the equation of the tangent line is going to be y minus the y value, which is 53. So y minus the y value, which is negative 53, equals the slope, negative 20, times x minus the x value, which would be x plus 1. There's the equation of my tangent line. How did I get the slope? I used the two formulas. Sometimes you'll be asked to show both of them. Sometimes you'll be able to choose which one you want to use. They're both just finding you the slope of the tangent line. Okay. How does this have to do with velocity? Well, remember from last time, average velocity is just your change in displacement over change in time. Okay, so I want you to think about average. So average velocity as slope of secant line. Okay, it's going to be between 2 points. Whenever you're asked to find the average velocity, it's going to be between 2 points. Your instantaneous velocity, sometimes just referred to as find the velocity, is going to be your slope of your tangent line, which now we can use either formula to find the slope of your tangent line, what we just did. Okay, so it's going to be the same thing. I can use your two limit formulas. So right here, the velocity at time t equals 0, t equals a, is equal to the slope of the tangent line at a, whatever that value is. Okay, so your velocity at a is equal to what? The limit as h goes to 0 of f of a plus h minus f of a all over h. You will know these very soon. You'll be using them so much that you'll get really confident with them. Okay, or I could use the other formula here. So here's a problem. A ball is dropped. What is the velocity after 5 seconds? So that's saying find the velocity at 5 seconds. Okay, also known as the slope of the tangent line at x equals 5. That's what that's asking right there. So right away, I know that a equals 5. Okay, so what am I going to use the h formula. So I'm going to say the limit as h goes to 0 of f of a plus h. So it would be 4.5 times a plus h squared, because there's my equation, minus 4.9 times 5 squared, f of a, all over h. Okay, again, simplify that, and you guys should get 49 meters per second. When I FOIL, combine like terms, the h should cancel, then I could plug the 0 in. Okay, so what's it saying? After 5 seconds, the velocity is 49 meters per second. Okay, and I use the h formula. You could use the f of x minus f of a formula to get that. All right. So we are going to finally say derivatives. So when finding the slope of a tangent line or the velocity of an object, you are finding a derivative. That's all a derivative is. Okay? So a derivative is usually referred to as a rate of change, which we know is just slope. So the derivative of a function, when I say that, at 2, just means the slope of the tangent line at 2. Okay? Or the derivative of the function at 7 just means the slope of the tangent line at 7. So now, here's notation. Derivative is called prime. So f prime of a means the derivative of f at a. And what's it going to equal? It's just going to equal the formulas that the definitions we've been doing. The limit as h goes to 0 of f of a plus h minus f of a all over h. Okay, or what? F prime of a equals the limit as x goes to a of f of x minus f of a over x minus a. Okay, so these just stand for what? The slope of our tangent line. And what does the slope of the tangent line equal? The derivative at that number. Okay, so now the only difference, find the derivative of this function at the number a. Then write the equation of the tangent line to the parabola at 3, -6. So first it actually just wants you to do it with a in the equation. Okay, so what? F prime of a. Okay, so that's what it wants me to find at number a, at any number basically is what it's saying. So pick which formula. I am going to use the h formula. So I'm going to say, what does this equal? This equals the limit, as h goes to 0, of f of a plus h minus f of a all over h. Okay? This is going to be a lot of algebra. Don't complain. Go ahead and plug it in. So I'd have a plus h squared minus 8 times a plus h plus 9. That's f of a plus h. Minus f of a, parentheses, a squared minus 8a plus 9, guys, all over h. Okay, simplify that numerator. Plug 0 in after you cancel, and you should get 2a minus 8. Okay, then it says then write the equation of the tangent line at 3, negative 6. So now that you have this, the cool thing is you could find the derivative at any number. So that's f prime of a. So now if I want when a is 3, I just plug 3 into that. So when a is 3, when f prime of 3 would just be 6 minus 8, which is negative 2. And then I could find the equation of the tangent line by doing what? Y minus the y value, which would be plus 6, equals the slope, negative 2, times x minus 3. Okay, I'm really hoping that you're doing all this algebra out that I'm skipping. All right, so in closing, rates of change. Suppose y is a quantity that depends on x. The average rate of change of y with respect to x is just the slope of the secant line. Anytime I'm asked for average rate of change, I'm talking about slope of secant line. Okay, if I'm talking about instantaneous, I'm talking about what? Slope of tangent line, which you're going to use the two limit equations that I've been talking about. What's the difference between speed and velocity? Okay, so the only difference between these, velocity is really just f prime of a. It's your derivative at a. If I want to find the velocity of an object, it can be positive or negative. Okay, speed is the absolute value of that, which means it's always positive. Okay, so velocity shows direction. If my velocity is negative, it means I'm going backwards. If my velocity is positive, it means I'm going forward. Last problem. If a manufacturer produces bolts of fabric, the cost of producing X yards of fabric is, the function's cut off over there, C equals F of X dollars. What's the meaning of the derivative? So the meaning of the derivative would be your rate of change of the cost with respect to how many yards are being made. Okay, so again, your rate of change of the cost, how much the cost is increasing or decreasing after I sell that many yards of fabric. Okay, what does this mean? What is F prime of 1,000? So that means after I make 1,000 yards, the rate at which the cost is increasing is $9 per yard. It's not what it costs, it's how much it's increasing. Because again, a derivative is a rate of change. It's not just a value. It's how much something is increasing or decreasing. Okay, and then this question you can think about, what do you think is greater? F prime of 50, 500, or 5,000? Okay, so what would be larger right there? The rate of cost after 50 items, 500, or 5,000? I'll let you think about that. All right, in closing, this is really, really, really important, this section. Okay, to know your two formulas. You will know them within a day. Your limit as h goes to 0 of f of a plus h minus f of a all over h. And you'll see we've been working, that's the difference quotient, with that for some time. It's because they're part of these formulas. Second one, okay, f of x over x minus a. And these both stand for the slope of the tangent line at a, which is also the derivative at a. All right.